we're going to be starting what's basically called proofs. Okay? Now, in life, when we're asked to prove something, you can't really use, well, just everybody knows that. Okay? It's not a proof. Okay? A proof is a way of showing something by using sometimes laws, identities, practices that are considered to be true. If I can just give you a really simple example. How can you prove x to the 0 equals 1? So 5 to the 0, 10 to the 0. How can you prove that equals 1? Well, we all know that's true. X to the 0 equals 1, right? But you don't get to just say, if they say prove it, what do you mean prove it? I just know that. Okay? Well, you could prove it using two other things that we know to be true to show that. So, what is anything divided by itself? 1. See, that's considered to be true. 10 divided by 10 is 1. 30 divided by 30 is 1. So what would x to the 6 divided by x to the 6 equal? 1. Another thing that we know to be true is that when we divide powers, what do we do with the exponents? Subtract. So x to the 6 over x to the 6 would equal x to the 0. So therefore, what does x to the 0 equal? 1. Okay? So I've proved it using two other laws. The law that if you divide anything by itself, it equals 1. And the law that if you subtract exponents, or divide powers, you subtract the exponents. So therefore, x to the 0 must equal 1, right? See, that's a proof. So today, you're going to be proving, and as we go on, you're going to be doing a lot of proofs. Now, proofs are really hard to do without tools, without other things. I could not have proved this if I didn't know those two laws of division by itself and division of powers. So you're going to have to build up an arsenal. Now what you have is this entire side of your study sheet. Now, you may think, well, that's pretty cool. I got them all, so this won't be hard. Well, the problem is practicing with them. Because actually, if you don't practice with these tools, you won't even know they exist. So you won't use them. Now, I don't know if you've ever known anyone that's gone into law from law school, but you don't go right into law school and become a lawyer. You have to do what's called articling first. Now, what articling is, the word is pretty self-explanatory, is the lawyer that you work for will ask you, every time you do a case, to go down to the law library, or he'll have a lot as well, in the law library at U of A, and go get me these articles. These articles are past precedents or things that can help you with the court case. A skilled lawyer, while doing law, while being your lawyer, will bring up other cases that will help you. Now, how on earth do you know those other cases exist? Because when you start out young, you're going to do all these articling, and you're going to find all these articles, and you're going to get good at knowing what they are, where they are, what's going to help your case, etc. So that's why you don't just start out in law. You do so bad because you wouldn't even know what to use, what laws there are, because you won't know every law coming out of law school. It's not how it works, right? You gotta practice. And same with these. If you don't do the homework, you just won't get good at them. And if that happens, you just have to write those off on the exam, okay? Now, here's some of the basic ones you need to know. Okay, you can see them right here. Also know the reciprocals. These are all common now. Now, what if, I'm just going to go right down to here. What if I need to prove that tan theta equals sine over cos? Well, it's like, but we just know that. So here it says, I need to prove it. Now, proving it is not saying it is because it is. Some people actually use that. If you wanted to prove that I wasn't parking in a no parking zone, how would you prove that? Take a picture. Yeah. Yeah, my wife's car got towed one time in this parking lot. We couldn't find anything, and I'm not kidding you. The sign was on the ground, covered with leaves and dirt. I took a picture of that. I said, "You can't do that. Like it's not lawful, right? It's not. It's tricking people, or whatever." So then, they let it go without the $70 fine and all that stuff, right? But you got to take pictures, right? Because if you don't, if you're arguing it, while you're arguing it, another guy could be on the phone saying, "Get that sign up now." Okay? So, you got to take pictures of it when it happens, obviously. So, how am I going to prove this? Because I can't just stand there and say, I shouldn't get a fine because I shouldn't. I can look at me and go, well, you should because you're in our parking lot, right? So it'd be a waste of a drive. So how can I prove that tan equals sine over cos? Well, I know that tan equals y over x, right? So I'm just going to write this out. Tan theta, and this is sine theta over cos theta. And tan equals y over x. Okay, well, yeah, so, well, I'm going to work with the complex side now. Well, I know that sine is y over r. And I know that cos is x over r. Okay. And remember, this is the same thing as y over r times r over x. Those cancel. Y over x equals y over x. So I say left side equals right side. Done. Now, it's very rare you're going to be using x and y's and x's. Because you're going to have to learn more complex ones. And that's where we're going to go. Now, here's some other ones you need to know. Now, these ones you know already. Tan equals sine over cos. Just proved it. And cotan equals cos over sine. Now, even with this, I can prove this, because this is an inverse, or reciprocal. So this is also reciprocal. Now, here's some new ones for you. Now, this one is extremely common. We'll use it a few times today. Sine squared x plus cos squared x equals 1. This, 1 plus tan squared x equals secant squared and then the 1 plus cotan squared equals cosecant squared. Now there's also varieties of these. Like if you look at this one, these are also, see, this comes from this by just minusing 1. Right? So you've got to know all the little byproducts as well. Now, when we first go through these, you're going to be like, huh, I would have never thought of that. How do I know? I wouldn't know how to use that. You will if you do the homework. Only through redundancy will you get good at these. Only through redundancy. So, any lawyer that's been practicing for 30 years, yeah, he's going to rock it knowing every case. Because, not because he's a genius, but the fact is, through pure redundancy, he's used them all. Or talked to lawyers that have. Or they're at a firm that's done a case like that. I remember like 10 years ago we did this case, and he recorded all his articles. So he gets that case out, all the other articles. I mean, that's why you want an experienced lawyer, not some guy that's, just right out of law school, that's never done it before. He might not do the best job for you. So let's just get to it so you can see what I mean. Now, here's a kind of question that they will ask you to write as a single trig ratio. Now, that means one term. This right now is two terms. Sine squared x over cos squared x plus 1. Now here's a trick you're going to learn to do a lot. I need to add these together, but you can't just take that and add 1. So we want to do a common denominator. So do you know that 1 is the same thing as cos squared x over cos squared x? Now right away you're going, well, I never thought of that. Well, yeah, you will now, because we're going to do it so many times. Now, we'll add them, since they have a common denominator. So that's sine squared x plus cos squared x all over cos squared x. And just always remember that sine squared x, that means this. That's how you have to think about it in your brain, or else you'll miss some things. Now, what is sine squared x plus cos squared x? It's 1. So this is the same thing as 1 over cos squared x, which really is secant squared x. That's a single trig ratio. Okay, next one. One of the best things to do when you're doing any of these is get rid of cotans and tans. Tans are sine over cos, cotans are cos over sine. So you always want to change it to that. So this would be the same thing as sine x plus, cotan is cos x over sine x times cos x. Now sometimes it looks worse before it gets better. So you made it more complex now, which is not a great goal. You want to make it simpler. But this will equal sine x plus cos squared x over sine x. Right, I just took my coses and multiplied them by each other. Now, again, we're kind of looking at a scenario similar to this, where I am not able to add them here. But if I multiply by sine x over sine x, so I multiply by 1. You can do that. You're not breaking any laws of mathematics there. Multiply by 1. So this will give me, see, this will make sine squared x, and then plus your cos squared x over sine x. See, when you add two things together, your denominator stays the same. They have to be the same. What is sine squared x plus cos squared x? 1 over sine x, which equals cosecant x. But you've seen twice already where sine squared x plus cos squared x equals 1. So even now you should start knowing that one. Now, this one here says I want it written so there's only sines and coses in it. And they don't want any addition or subtraction signs, okay? Missed him. Now, there's sometimes when you learn more things, there's many ways to get to the end when you do proofs. And, you know, this one, if I look in the book, I'm like, what? Why did they do it that way? Like, they created this whole mess because they didn't see one thing. And the one thing they didn't see this. What does 1 plus tan squared a equal? Secant squared a. So this is the same thing as 2 tan a over secant squared a. So the author of the book didn't see that and did 2 more gigantic steps because of it. Or maybe he did. And he's like, well, let's get a few more proofs in here. But you want to look for those kind of things when you can. And the second thing is get rid of all reciprocals and all tans and cotans. So this is the same thing as 2 sine A. Oh, I'll do it like this, sorry. 2 sine A over cos A all over 1 over cos squared A. Yep. Oh, sorry. This is wrong. That square is bad. This? Okay. Now division can be quite complicated, so make it into multiplication. 2 sine A cos A times, remember the reciprocal, right? Cos squared A over 1. So dividing is the same thing as multiplying by the reciprocal. What can you do now? Now remember, this means this. That's cos A times cos A, right? So you see how we can cancel a cos A, leaving me with 2 sine A cos A. Okay, last examples here. Now these ones, we're going to factor them. Now, by factoring them, they may come up with something that is on your identities. Now, anything we can factor in A, take out a 3, Okay, anything else I can factor in there? It is a difference of squares, right? When you have x to the 4 minus y to the 4, that's a difference of squares. So this is 3 times cos squared theta minus sine squared theta times cos squared theta plus sine squared theta. Okay, where do we go next? Good. This all equals 1. We've used that 3 times now. You should know that one, right? What about cos squared theta minus sine squared theta? Difference of squares again. So that is 3 times cos theta minus sine theta times cos theta plus sine theta. And I don't have to multiply by 1. So that would be redundant, right? And that's as far as I can go with that one. Okay. B is a nice question. Doesn't look very nice, but it is. Now the book did it different than I'm going to show you here. But if you do what I told you right away, well, there's kind of 2 ways you go with this right away, I guess. You could take out a sine theta out of both of them, right? But before I would ever do that, I would actually get rid of all my cotans and tans. So doing that actually saves you work here. Now, if you take out a sine theta, you'll still get it right. But I'm going to show you the most efficient way. So this is sine squared theta plus sine squared theta. And what's cotan squared? What is it, guys? Cos squared theta over sine squared theta. So now you're going to see why this is kind of a nice move. Because, and what are you left with? Sine squared theta plus cos squared theta. What does this all equal? 1. Okay? Now, watch when you are doing proofs. Sometimes it'll say, put this value into the left and the right. So it's pi over 6. So you put pi over 6 and you get the same answer. Does that mean they're both the same? Okay. Remember, there's coincidences in math. And an example that I would show you even just kind of right by the assignment, x plus y equals x times y. I ask you to prove that. Now, is that true? Okay, but say they give you a value. They say put x equals 2 and y equals 2. Okay. 2 equals 2 times 2. 4 equals 4. Yeah, it is true. I proved it. It only happens with certain numbers. So they might rope you in. And you're going to get the same side, same answer. Now there's 2 ways, or there's 2 ways I can go about this. Try multiple values or try a proof. And I don't know how to prove this. It's so not true. It's hard to prove it's not true. Okay? But just watch. when you try 60 and you get the same answer, does that mean they're the same? Not always. Like when you get to this assignment over here, okay, and you try pi over 6 and 120, it says, is this sufficient to include the identity as valid? If you try some other identities or other numbers, you may see it doesn't work. But I could go about this one maybe using proofs to see if it works or not. Okay, so today will, I'm sure, be challenging for you. Have your formula sheet out. Keep looking at it. Okay, remember sine squared theta plus cos squared theta equals 1. We used it 4 times in the notes alone. So we're doing 1 to 8, A, C, and E, and 9 to 16. Okay, you have lots of time. Get stuck on anything, you know where I am. But please don't be talking, because this is a difficult time of year to have homework. And because of that, learning goes downhill. Get it done in class, then learning won't go downhill. And you can still maintain a healthy social life. Okay, so